Good afternoon, all of you. This class is the continuation of haloalkanes and haloarenes. Yesterday, we were in the middle of this chapter, that is the preparation of haloalkanes. There are three methods of preparation. Once again, I am going fast through this classification. One is from, not classification, preparatory methods. One is from alkanes. We can prepare from alkanes this haloalkanes. Second preparatory method is from alkenes. In this session of alkenes we have learned Markovnikov rule, Karash effect or peroxy effect. There we used this alkene plus hydrogen bromide. Why we used hydrogen bromide instead of chlorine, hydrogen chloride or hydrogen iodide? You see, for this purpose, this hydrogen halide must be donated free radicals. What is meant by free radicals? A single atom consisting of positive charge. Okay, a single atom having positive charge. You know, these halogens are non-metals, so definitely, of course, they are having negative charge. Cl minus, Br minus, F minus, I minus, etc. Radicals means iodine radical means I plus. Bromine radical Br plus, fluorine radical F plus, Cl radical Cl plus, like that. So we used hydrogen bromide here instead of Hi or HCl because hydrogen bromide provides Br plus. This is the bromine radical. This is the bromine radical, Br plus. So when we use HBr, by splitting this HBr, H will become positively charged ion, Br will be negatively charged ion. This ion will donate one Br plus radical. Instead of HBr, if you are providing Hi, so I free radical will be formed, but coupling process will undergo. Coupling process means from one molecule of I plus, that is iodine radical will be formed, and it will react with the I plus, that is iodine radical, to form I2 back. So again Hi will be formed. So what is the use of that process? So this haloalkane, for the formation of haloalkane, these alkenes will not get I separately, okay, Cl separately. So to avoid this problem, inconvenience, we have to use HBr here, okay. And the addition of halogen, we already learned what is meant by vicinal dihalide, vicinal dibromide we prepared from alkene, that is ethene. Ethene is treated with bromine, that is Br2, in the presence of carbon tetrachloride, that is CCl4. We got this vicinal dibromide, that is the compound, okay. And the last preparatory method, that is from alcohols, So here the chance or the possibility is there to ask one question. From alcohols we can prepare these haloalkanes by using halogen acids. Halogen acids are HCl, HBr, Hi, HF, etc. So here we are treating this alcohol, that is ethanol, C2H5OH, with the HCl in presence of zinc chloride. This zinc chloride must be anhydrous. Yesterday I explained what is meant by anhydrous. Anhydrous means there won't be there won't be a single molecule of water there, completely that dehydrated. No? So by the removal of these complete molecules of water from the zinc chloride, it will become anhydrous zinc chloride. Okay. Why we use the zinc chloride? Before that we have to CH3, CH2, haloalkane we got ethyl chloride or chloroethyl, and water will be removed from that. So we prepare haloalkanes from alcohols. Sometimes the question may come, why we use the anhydrous zinc chloride here? We all are knowing this basic thing. Zinc chloride is a Lewis acid. Lewis acid. You see, actually we are preparing this ethyl chloride, that is a haloalkane from alcohol. So this, you see the structure of, this is like this, C2H5, okay, that is CH3, CH2, OH. When we draw the structure, CH3, this is the CH3, CH2, OH will be linked with this functional group, will be linked with the carbon atom will be bonded with the oxygen atom of OH. That is alcoholic group. So you see the bond between C and O. So what will happen, you know, this, if we are using this Lewis acid, that is zinc chloride here, this zinc chloride will coordinate the process, that is, this zinc chloride will coordinate the bond between C and O. As a result of that, the bond between C and O will be weakened. Weakened means its strength will be reduced. It will become weakened and breaking of CO bond, and this OH will be removed. And who will come here? You see, who will come here? This Cl will come here. So CH3, CH2, Cl, ethyl chloride or chloroethyl as formed here. Okay, this is the reason for using anhydrous zinc chloride as the intermediate or whatever. We have to mention, this is the importance of the reaction of organic compounds. Very early I told you this is very important, and this ethyl bromide and ethyl iodide also we prepared, and for the formation of ethyl bromide we have to keep small quantity of acid in acidic medium. It yield this alkyl halide. The third case, that is ethyl iodide, reflux reagent must be there. Okay, so second method from alcohol is by using phosphorus halides. So generally we used to take two types of phosphorus halides. One is PCl3 and another is PCl5. That is phosphorus trichloride, and another phosphorus halide is called phosphorus pentachloride. These two are the important halides of phosphorus. So nothing to explain, that is alcohol when reacted with phosphorus trichloride to give. Yesterday I have given the note. You see two compounds will be there. Sorry, three products will main compound. Main product will be there, along with two more byproducts will be formed there. In the case of alcohol, when react with the phosphorus pentachloride, again you will get three products. One is our major product, that is alkyl halide, along with the phosphorus hypotrichloride, and the HCl also will be formed. The last method to prepare haloalkanes from alcohol is using thionyl chloride. Thionyl chloride. Thionyl chloride means SOCl2. It is SOCl2. Thionyl chloride. So you see, same alcohol we are using, that is primary alcohol, that is ethanol. CH3, CH2, OH is treated with thionyl chloride in presence of pyridine. I hope you searched the structure of pyridine from the last year's textbook. This pyridine, so you will get CH3, CH2, chlorine will come here, that is chloroethane or ethyl chloride. Along with it, there will be two types of gases will be evolved along with this main product, that is the haloalkane. They are sulfur dioxide and another is hydrogen chloride. You see, sulfur dioxide has pungent smell. Both are colorless gas. This sulfur dioxide gas has pungent smell and it has a bleaching effect. While evolving this sulfur dioxide gas, if you are showing a red rose petal or jute, that texture something else, the substance which is made up of jute, anyhow organic substance must be there. So rose petals you can show reddish color, red color rose petals if you are showing, it must be little wet, okay, wet rose petal, so it will become white color. So that much reduced bleaching effect is there in the case of this sulfur dioxide. So this actually in this case mixture of HCl and SO2 will be evolved along with this thing. So this reaction has one importance, because if you want to prepare haloalkanes in purest form, we can choose this method. That is preparation of haloalkanes from alcohols in the presence of this thionyl chloride or reaction with the thionyl chloride. When alcohol is treating with the thionyl chloride in presence of pyridine, and the chloroalkane will be formed and along with the sulfur dioxide gas and the HCl gas also be formed there. If you want to prepare purest form of haloalkane, you can approach this method because the byproducts are, both the byproducts are in gaseous state. So during this reaction, this mixture of these two gases will be evolved out. Only the haloalkane will be remained left there. That is chloroethane or ethyl chloride. So this compound will be, this organic product will be absolutely in purest form. So I think you got the importance of this reaction. So the product will be in purest form. Okay. So this reaction is over. We could call this reaction as Darson process. Darson process. This is very important. In the case of these name reactions, Darson process has an important role, it has a key role. So sometimes the question may come, which reaction is, following reactions is known as the Darson process. So you have to remember, you have to keep one point there. One is the intermediate reagent, that is pyridine, another is sulfonyl thionyl chloride. That is thionyl chloride. You see, the reaction with the alcohol and thionyl chloride is it is from the section of preparation of haloalkanes. Okay, so purest form of preparation of haloalkane it is. So we could call this process as Darson process. So it is over. Yesterday we just entered into the fourth preparatory method using halogen exchange method. Using halogen exchange method. So in this case, two types of name reactions are coming. One is Finkelstein reaction. Number 1, Finkelstein reaction. You see, this method is used to prepare iodoalkane using sodium iodide in acetone. In acetone means acetone will come just above the keys. Understood? So same as before, one haloalkane, that is methyl chloride or ethyl chloride we are preferring here, and treating with sodium iodide, sodium bromide, etc. And this halogen exchange, that is bromine will go there and iodine will come here. So what is the peculiarity, what is the specific feature of this reaction is that if you want to prepare chloroalkane, bromoalkane, etc., so many, especially this chloroalkane, so many methods are there. But this is a special reaction. If you want to prepare iodoalkane individually, if you are giving preference to the preparation of iodide alkane, that is separately or individually, you have to do this Finkelstein reaction. RCl means this R is that is the alkyl group, or plus NaI, sodium iodide, in presence of acetone. In acetone or in presence of acetone, Ri will be formed along with NaCl also. So CH3Cl or CH3Cl or CH3CH2Cl also can be here. So anyhow you will get this is a haloalkane. Okay. So CH3I, methyl iodide, CH3CH2I, that is ethyl iodide, CH3CH2I, propyl iodide. Anyhow you will get a haloalkane there, or alkyl halides will be formed there. Okay, one more big reaction is there. This is also very important. Schwarz reaction. In this case, fluoroalkane can be prepared. From this method, we could prepare fluoroalkane. So till now, this character didn't come in front of us. This fluorine. Yesterday I told you, day before yesterday I think I told you, fluorine is the head of the family. Which family? Halogen family. So it has special properties. It's a rebel. So some kind of special reactions will be there. There will be this character will appear. Now, so this fluorine is a special element. So it will come in rare cases. If you want to prepare fluoroalkane or alkyl fluoride, let us treat alkyl bromide with AgF. So for fluorination, one compound must be there. If you are providing silver fluoride there, when during this reaction, anyhow silver and fluorine will be split, and Ag2 plus ion and this fluorine minus ion will be formed. So this fluorine will come here and bromine will go there. This is a halogen exchange. There are two halogen atoms are here. One is bromine and the rest is fluorine. Bromine is with the alkyl group and fluorine is with the silver. But resultant effect is that this CH3 receives fluorine from silver. Okay, that is methyl fluoride, and this silver receives bromine from this methyl group. So what happened here? The bromine atom from this methyl group attached with the silver and the fluorine atom from silver attached with this methyl group. So anyhow you got one alkyl halide, that is a haloalkane called fluoromethyl or methyl fluoride. This is the last preparation of the haloalkanes. Here fluoroalkane is prepared by halogen exchange and alkyl chloride or bromide is alkyl bromide. Chloride also can be used here. Okay. Alkyl bromide is heated in the presence of metallic fluoride. Instead of this AgF, you can use Hg2F2. Okay. Otherwise, cobalt fluoride, COF3. You see, valency is different. Understood? That is why their fluorides are like this. Hg2F2. That is mercuric fluoride. Okay, and cobalt fluoride, COF3. So we will learn more about this kind of compounds in D and F block elements. Okay. Anyhow, the preparation of haloalkanes over. Okay. There are four preparatory methods. One is from alkane, second is from alkene, third is from alcohols, and the last preparatory method of haloalkane is by halogen exchange method. Okay. In this case, two major main reactions are coming. One is Finkelstein reaction. Number two, that is Schwarz reaction. Please, children, it's very difficult to keep in your brain these all main reactions. Only this which in forthcoming that cases, some more than 5 main reactions are awaiting for you. So better whatever the reactions daily you are getting, that day itself you have to remind itself by doing it. Okay, like a mathematical work, you have to write each and every reactions without looking at your book. First you read, first you get to the class, first you that understand the thing, and try to write first without looking at. If any doubt came, you can look at your notes. Okay, doesn't matter. But third time it must be by heart. Otherwise, problem is there because confusion will come. When we go to the next session, that is preparation of haloarenes. Preparation of haloalkanes are over. Next we are going to preparation of haloarenes. Okay, a small portion it is. After that, the chemical reactions of haloalkanes and haloarenes. So our chapter will be finished. So in between, physical properties of haloalkanes and haloarenes are coming, and some halo derivatives of some compounds. We have to introduce some chloroform, carbon tetrachloride, and DDT, like that will come. Okay, just that have to go through it. But a major portion after this, that is preparation of haloarenes. After the preparation of haloarenes, we are going to the chemical reactions, chemical properties. So have to give more importance because all the reactions are based on some concepts. So you have to grasp the concept thoroughly. Otherwise it is a little difficult. You may feel some difficulties. Okay. Preparation of haloarenes. Write down the heading. Preparation of haloarenes. What is meant by haloarenes? Halogen derivatives of aromatic compounds. Halogen derivatives of aromatic arenes. Halogen derivatives of alkanes are known as haloalkanes. Halogen derivatives of arenes or aromatic compounds are called as haloarenes. Okay. The first method from arenes. Very simple. From arenes. Arenes means the best example for one arene, that is benzene. So direct halogenation will be there. Direct halogenation. Okay. So chloro-bromo-arenes can be prepared by the direct chlorination or direct bromination in the presence of in presence of some catalyst, that is metallic chloride, metallic bromide, like that. Okay, FeCl3 or FeBr3. If you want to brominate, so FeBr3 can be used here. If you want to chlorinate this aromatic ring, just you use this FeCl3, that is a ferric chloride. Okay, anyhow, but one thing is very important here, you should not keep it, this reaction must be taking place in the absence of sunlight. In the absence of sunlight. Okay, so let us write. Once again, I am telling this reaction. Haloarenes can be prepared from arenes. This is the reaction in which the direct halogenation is taking place. For example, chlorobenzene can be prepared by treating benzene with FeCl3. Bromobenzene can be prepared by treating benzene with FeBr3. That is ferric chloride, ferric bromide respectively. Okay, so let us write this chemical equation. Please write down, this is benzene. Chemical structure is very convenient for us for making chemical equations. Okay. When you go through the textbook, sometimes C6H5 will be there. Instead of this benzene, C6H6, it is okay. But after adding one halo atom, it will become C6H5, that is benzyl. Okay. Anyhow, this is an aromatic compound, arene. So it is treating with the chlorine in presence of FeCl3. Cold and dark. If light is there, so the presence of sunlight will be there. So to avoid the presence of sunlight, this reaction must be taking place in the dark room. That is laboratory, not near window, not near light. Okay, maximum we have to avoid the presence of sunlight. So dark room is the perfect atmosphere, that is the environment for this reaction. Okay, chlorine gas is treating with the benzene in presence of to enhance, to boosting up this reaction. This compound, the presence of this compound, that is ferric chloride, FeCl3 must be there, and reaction must be under another two conditions. The room must be dark and atmosphere must be very cold. Atmosphere making cold, air conditioner inside the laboratory is not possible. So we have to chill. We have to make it cold, these two substances. Okay, cold benzene. And when we pass this chlorine gas to a tube, so condenser can be attached to this tube. So anyhow, these reagents can be that cool during the reaction. So in this environment we will get here benzene is treated with the chlorine gas. So chlorobenzene will be formed here. This is chlorobenzene. Okay, and one hydrogen, one C will be one hydrogen will be removed there. Instead of that hydrogen, chlorine will be there. You see, any reaction, that is formation of haloalkane or formation of haloarene, when hydrogen atom must be removed from it. In other words, hydrogen atom will be displaced by halogen atom. Here also that will happen. From the benzene ring, these 6 points of carbon atoms. No need of mentioning, there will be hydrogen atom. So one hydrogen atom is replaced by one halogen atom, that is chlorine. So its name is chlorobenzene. Chlorobenzene. Okay. Chlorobenzene and HCl. This removed hydrogen will react with the only proton left here. So you will get HCl. Let us make bromobenzene also. Okay, this benzene is treated with bromic gas, brownish color, brown color gas it is. Okay, what would be the color of this chloride gas? That is a yellowish green. Okay, so Br2 gas in presence of same thing, FeBr3, very easy to write this chemical equation. Okay, so you will get bromo, ethane and HBr instead of HCl, so we will come, this HBr will come. Okay, write down the chemical equations.